So the fact is we started here and we took our 8 to the x, okay, right here, and we took 4 to the x plus 1. The goal was to take the whole number, the base, 8 and 4, and to rewrite them as bases with the same base, or numbers with the same base. So 2 to the third is 8, and 2 squared is 4. What do we do when we have a power raised to a power? We multiply to get 3x. Okay? And so if we'll go ahead and multiply that out, then we get 3 to the x equals, 2 to the 3x equals 2 raised to the 2x plus 2. Here's the important part. Here's the easy part. If the bases are the same,
What's that mean?
the base of the... Hold on. You need to understand what you're looking at. Every number that has an exponent has a base. What I'm raising to the power, in this case 2, that's my base. The exponent, of course, is easy to see. The base is also if you know what you're looking for. So the fact is we have the same values here and here. When the bases are the same, the exponents are equal to one another, so we're allowed to do this. I can drop the bases, set the exponents equal to each other, and now it's just an easy algebra problem. Solve for x. What do you get?
3x equals 1x equals 2.
X equals 2.
How did you get that?
Because you subtracted 2x.
I subtract.
Bottom left you did last year.
3x minus
Yes, several students have said we did this last year.
Yeah.
The bottom left you did last year.
Okay? We're just solving. You set the goal, once I get my bases equal, I solve it, and I'm done.
There's the whore.
Example number 2. This one is very different. This one, you're not going to get this one by guessing. Okay? It's problems like this where the answer is not a whole number. You're going to need a calculator to do this one. Can you tell me, just by the deductive reasoning, why would I need a calculator for this? How would I know that I need a calculator without even...
23 is not correlated to 8.
There you go. 23 and 8 don't share a base. In fact, 23 is prime. 23 is 23 to the first power, and that's it. If I could say it was 2 to some power, we're good, but I can't. So, here's how we solve these. My problem. You listening? My problem is the fact that x is inside an exponent. How can I get that exponent down? Can't. Previously, if I could get both sides with the same bases, I just let the bases go away and I have the exponents equal to one another. But how am I going to be able to get that exponent out?
Oh, the little square root. Never mind.
No, keep them with
How is it?
Is it that?
Not almost that.
It's point like 5, 3.
It's close. It'd be 23 exactly. Okay? So, well, let's just watch. Shh. Why would I do what I just did?
That'd be 1.
Okay, watch.
What just happened?
Shh. Listen carefully. Can you tell me, and this is easy, what's the base in the original part? The base is 8, right? That's going to influence my decision. I have to take the log of both sides. If I can take the log of both sides, then I have a way of getting the exponent down out of that exponent and make it just a regular number. So what you have to do is you have to take the log of both sides with the base that already exists. So it would be log base 8 of 8 to the x. What is log base 8 of 8 to the x? You're right, it's just x. And I would figure this out, and my final solution turns out to look something like this. before I use my calculator. That, log base a to 23, well, I don't know what that is. I can't do that in my head, definitely. But I can use my change of base formula. That's why this is important today. We change the base. Well, I won't change the base, but we basically need that base so that I can take the log of both sides. Shh. On the screen, you have a logarithm, and it has a log of something equal to the log of something else. Okay, look at the other equation. You have log of x plus log of x plus 3 equals 1. I want you to notice the differences in the equations. One of them is log equals log, and that's it. Is it possible for me to get the other side to be log equals log? Can I get this one? Can I get this side to be just log equals log of something?
No.
Is it possible without any extra parts?
Yes.
No.
With extra parts. I'm optimistic. Anything possible.
Let's be serious for a minute. It's not possible. This one, listen, Marquise, sit up. This one is easier. Do you remember how we said if we can get the same base on both sides, I can just let the bases drop and let the equal part of the exponent be equal? This is exactly the same idea. If you can get it to be log of the same base on both sides, what do you think happens? They effectively cancel out, and you're left with just the inside part, and so it looks like this.
I was right.
Shh, pay attention. So what's the answer?
I don't know.
Simplify it.
That's a good question.
X plus 6 equals 4 minus x.
It's -1.
So we're going to add x to both sides, and I'll go ahead and subtract 4 from both sides, and x becomes -1. Write this down. You must check your answers with logarithms. The domain for a log is not all real numbers, and that's all that it matters. Because that means that you have some x's that don't work. There are some x's that if you plug it into your calculator, log of something would give you error. If that's the case, you need to make sure that this value doesn't make that happen. Now, your number, like this is -1, that tells you nothing. -1 may work, it may not work. What depends on is when you plug it back into your equation at the top. Okay? So if we plug this in and just look at it, what's going to happen? Log of what? Yeah. And so you both get log base a to 5 equals log base a to 5. Which is it doesn't equal 1, but it's the same.
You know what I'm saying.
It works. So this is good to go. Now, careful. Shh, listen. This is the one that's going to take a little more work. Anybody have a question about the first side? That's the easy version.
Oh, is it harder?
That one works just like the exponential did. You just drop that one part, you set them equal. Now that can get more or less difficult depending on what's in the log. Look at this part. Shh. Let me give you the tip of how to do these. The tip is whenever you have several logs on one side, not equal to a log itself, but equal to a number, you need to condense them so that you just have one log on one side. If I've got multiple logs on both sides, then condensing them down to as small a value as possible might make it even easier. Sometimes that's not possible, like this one. So we're going to condense one side. And so you get this pretty much, right?
That's what I got. I'm lying, but yeah.
What happens is, remember I told you over the weekend, well, I didn't tell you over the weekend, but I told you Friday that this is the building blocks to doing what we're going to do next. And this is why you needed to know how to condense and expand. Condensing is more valuable here than expanding because it's one of those things where I need to get it to some log. How do we get rid of, well,
Brackets.
what?
How do you get rid of brackets?
I'm going to go ahead and multiply through. And so I end up with that. My question is, do you remember how we got rid of the log? Excuse me, I didn't see you there.
That was a line or something.
What do I do?
Exponential.
Good. I need to turn it into exponential form. And so, in order to do that, I actually need to know the base. I didn't write the base. What is the base?
10.
It's 10. Right? So we're going to raise 10 to what power? If I convert it to exponential, what do I get? Say it one more time.
X to the x squared plus 3.
Equals what?
1.
No.
Oh,
10. What?
Shh, watch. I take 10. I raise it to the other side power, which is just 1. So I'm going to get 10 equals, 10 to the first power equals the x squared plus 3x. Does that make sense?
No.
The base was 10 because if the base isn't written, it's log, it's automatically 10. It's called a common log. That's what your calculator uses, what most of the time we use. So they don't write it. So it's just called a common log. If it's not written, if it's log and there's nothing there, it's always 10. Anybody not quite sure how we got here?
Yeah.
Abby.
All of this. I don't know where you got any of it. Like,
Let's
how
go
do
back
you
for a minute.
put brackets and then the X.
Oh, the first part was your homework over the weekend. Condensing. If I'm adding things together.
I never had any brackets in those answers.
Oh, brackets doesn't matter. I could have put parentheses there.
But still, we didn't get this.
Let's do an example like that one. One more time. I took the base. I raised it to the power on the other side. It's equal to what I'm taking the log of. Sit up. Get some water. I'm tired too. It's going to be a long week. After 2 short weeks, it's going to be awful. Tim's handing out Adderall over there. I don't think so. Yeah, whatever. Okay, let's be legal here. Whatever. Once we get here, what happens? Okay. Subtract 10 from both sides. Factor. Ooh, what's factoring? Ooh. What is factoring about? How do I factor that problem?
Plus 5, plus 2, 7.
It's going to be 5 and a 2.
Negative 2.
5 and 2. Which one's 5's positive? Why? Perfect. 5's positive because the 3's positive. It's the larger number. It gets the second or the first sign. The last sign's negative. Tells me that they're different signs. Now the question is, do both of them work or not?
No, you have to figure it out.
You tell me. Plug them back into the original problem. Plug it back in and tell me which ones actually work or not.
They can't be negative.
As long as if I plug the number in and it makes what I'm taking the log of negative, it doesn't work. So plug in the positive 2. Okay, go back up to the top. 2, that's good. And 2 plus 2, that's 5. So log of 5 and log of 2, check. They're not, no problems.
Wait, that does not add up together. Does it? 2
Yeah.
and 5 does not
It's log of 2 plus the log of 5.
doesn't equal 1.
You sure?
No.
Try it.
Wait, I don't even know what that means.
I don't either. It's okay. What happens? Shh. Kelly, what are we really looking for?
I don't know.
I didn't want you to work it out. Shh. What I wanted you to do was to plug it in and see if you got negative numbers.
Is that bad?
Yeah, you can't have them. For example, look up here. Look on the screen. if I plug in -5 right here, it's log of -5.
Yeah.
I can stop. That is not allowed. If you get and you plug the number in and it's negative, it tells you that it's not a valid answer. So
Do you have a calculator?
you'd mark it off. Yeah,
Yes.
type it in.
Log of a -5.
See what happens.
-5 and then hit log.
Yes, ma'am.
Yeah, that's what he's trying to tell you. It's impossible, you can't work